Hello and welcome back to another particles video. I'm going to give up on trying to think of a catchy name. Today we're going to be looking at the way that particles interact with materials. It's like a crossover episode, you know? Materials are kind of ironically the most important part about particles. So, you know, particles, they are moving around, they're doing their stuff, you know, whoop-de-doo. Materials is kind of what takes them to the next level. So we're going to jump straight in, and we are going to make a new material. This is going to be called tutorial particle shit. Now, this tutorial particle material is going to be a sprite. So you can see here we've got a square. We're just going to say base color. You are going to be a color, blue. Blue is my favorite color. Then go to our tutorial material particle thing. On emitter update, we're going to do a spawn burst instantaneous, which is going to spawn 100 particles. And on particle spawn, we're going to add velocity. So you can see now we've got 100 particles. They're all just, you know, spurting out in a random direction. Now, this is where it gets quite pog. In the sprite renderer section, we're going to click this and we can choose what material our particles are going to be using. Now, by default, they're going to be using the default sprite material. Pretty obvious. But we are going to search up our, there it is, tutorial particle shit. And you can see they are just these fucking blue squares that we set up in that material. Very amazing. Yeah, 10 out of 10. Really good job, go team. What are we going to do with these? Well, I'm glad that you asked. One of the most important things when you're doing custom particle sprite thingos is they should always be circular, unless you're doing something really specifically square with hard edges. So what we're going to do is we're going to go to the blend mode of this material. We're going to set it to masked. You could set it to translucent, but as you know, translucent particles or just translucent materials in general are a bit of a GPU hog. I tend to just use masking and dithering. So what we're going to do is get this radial gradient exponential. We're going to put it into the opacity mask, hit save, and bam, we have a damn circle. Now, if we go back to our thing, you can see that these are all circular. So let's go back into the material, and we're actually going to have a look at all of the particle related nodes. All of these particle nodes, you'll see that they're all red input ones. All of these, by my understanding, relate to some custom data because particles are all instanced together. They're using like custom primitive data or something. All of these exist on the particle anyway, and it's just binding to that, kind of. So if we were to go particle speed, we're going to get the speed of the particle. So if we said particle speed, let's divide it by 400. 400 speed equals 1, and 0 speed equals 0. We're going to saturate that. Then we're going to smash that into an MF lerp. Put that into the base color. So then we're going to say at max speed, these will be white. Or maybe we'll just say they're red, just so we can get some really fat contrast. And then when they slow down, they're going to be blue. So we hit save. And we go to our tutorial material particle blah blah blah. Okay, wait, hold on. I can do this. I can do this. I need to make them faster. You can see when they start and they're going fast, they're going to be red. And then as they slow down to 0, they're going to turn blue. So this is a really simple, easy thing that you could do with particles. Let's say you had like some sparks and you wanted them to glow more when they moved faster. So the next one we're going to look at is the particle color node. You can see that this by default is just white. Now, particle color gets set firstly in initialize particle. So we can go color mode, direct set, and just say, hey, you're going to be red or something. We could also do within, you know, a random range, directly in the particle system. We can also do things like on particle update. This will be very similar to what we did before in the material, but more on the particle side of things. So we could get the color, color without a U. We could just say color on particle update. And you can see here, it's just setting it to be white on every particle update. But we could say curve, color from curve. And you can see here the curve index is currently the normalized age. So as they go from beginning being 0 to 1 being the end of their life, regardless of what their lifetime is, we can change the color. So we could say as these particles get older, they're gonna turn red. There you go. Now we could set the lifetime to be random range float. So we could say between 3 and 6 seconds, and they'll all age at different rates. You can also add extra ones in the middle, so we could say we want them to go blue from white and then turn red as they age or whatever. And keep in mind that the alpha is also affected here. So if we got the opacity here and set that so that it's opaque all the way towards the very end. Now you can see that these aren't doing anything special, but if we go back to our material, we can actually access the alpha here, and maybe we could multiply this by that, and we'll chuck that into a ditherino, just because we're not using translucent material. You can see that we have these kind of fuzzy particles now, and as the alpha drops from 1 to 0, they kind of fade out. So you might be thinking, hey, this looks, you know, pretty cool, but we don't want all particles to fade out, you know, kind of smoothly like this. So one of the most important techniques to know about particles is height lerping. Now, I have a materials video, which I'll put up in the little corner, that goes over height lerp, but essentially what it is a noise texture. So I'm going to get my baked cloud noise. We are going to subtract 1 from the texture, and then we are going to multiply this by 2. Then if we add them together, I'll just do these like by themselves real quick. So let's just say we had a parameter that's going from 1 to 0, and we're going to put this into, let's just put it into the base color for now. So you'll be able to see as I put this down from 1 down to 0, it's kind of blending through this noise pattern, going from purely white, blending through the noise, and ending up as purely black. Usually you'll add a contrast after this though. Instead of this parameter here, we're going to be using the alpha from our particle color. The particle color is going to go into the particle base color, I guess. And then before we do the contrast of this, we're actually going to multiply our radial gradient exponentiation into here. And that's going to go into the contrast. So now this will go into the opacity mask. And you'll see we have our particle, and it's round. And then if we go back here, you'll see that when they fade out, let's make them fade out a bit slower. So like from halfway through their lifetime, you'll see that they fade out in these kind of this kind of noisy way, which looks quite appealing. Now you can see it's a little bit jarring because all of the textures look the exact same as they fade out. So you can see like the actual pattern itself is all in the same like format. It looks a bit silly. So one thing that we are going to do is get another particle node called particle random, which is just going to return a random 0 to 1 value into the particle's material. And we are actually just going to add that to the text coords You could do some whack shit. You could say particle random value multiplied by, you know, 2 prime numbers or something that are like big, like, I don't know, 27 and I don't fucking know. Just 2 numbers that aren't going to overlap very often. And then add that to the text coords, then put that into there, and that'll ensure that there's like a ton of randomness in the actual UVs of the particles. And you'll be able to see that all of the noise fade outs are different from one another in, you know, terms of location and whatnot. So, you know, that is quite poggers. So, carrying on from having this fading out noise, blah, 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 let's just set it back to not have any randomness. One really useful particle node in the materials is particle radius. And what we're gonna do is, in our particle thingo, we are going to, on particle update, scale sprite size. And this will be scaling over the normalized age of the particle. We also have to set the particle sprite attributes to have a uniform set sprite size. Let's just set these to 100 by default. And we are going to scale sprite size starting at 1. And they are going to end at, I don't know, 5 times their size. Now, if we had the color, like, fading from the get-go, you can see that as these get bigger, the texture itself gets bigger as well, which might not be what you want. If you wanted the texture to stay the same size as the particle gets bigger, then you could use particle radius. We get the reciprocal of the radius, we get the text coord and offset it by -0.5. That's gonna bring the corner of 0 to like the middle of the thing, so that when we scale it, it's going to scale from the center of the UV space. We are going to divide this by this, and then we're going to divide that by whatever number to scale the thingamajig, to scale the texture. So if we now go back to our thing, you can see that as these particles get bigger, the size of their respective textures is staying the same size. So if we just did like, let's do 1 particle. So you can see this, as it gets bigger, the size of the texture itself isn't scaling at all. It's staying the same size. It'll be a lot more obvious, actually, if I should have done this in the first place, but if we just got this and plugged it into the base color, and we didn't do any opacity mask, then you'll be able to see here, this texture stays the same size as the sprite card gets bigger. Very cool. Wow. Poogers. We could add all this shit together. We could have the, you know, the sprite size, blah, blah, blah. Then we can add before... we're just going to brute force it until it works, basically. Okay, so with this setup, taking our, you know, random texture offset thing, and our particle radius texture stabilizer thing, put particle color back into the base color, and, you know, we could make these look interesting. We could do something like color and start them as, I don't know, yellow, with a value of 100. Hold on, wait for it. And in the material, we will plug the color into the emissive color as well. So this is going to create a lot of bloom because of low dynamic range rendering. So you can see here, it looks like a kind of explodey thing, you know? Wow, good job, good team, wow. Shwow, shwow. So there you go, there's like a little fucking explosion from that simple effect. Now you can see how particles and materials interact with one another. If you use Lumen to cast light from the emissive tube, that is true, that is true. This would work with Lumen. Alright, so this looks pretty good. We've learned a lot so far. We've learned about all of the, well, most of the particle node things. If you just type in particle in your material editor, you'll see a lot of particle blah 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 blahs. You know, particle size by pixel units, which is like a screen space size thingo. You can get the particle's position in world space, which gives you like the origin point of the particle in world space. Particle direction, blah, blah, blah. You get it. Lots of particle things. Now, the most important one, which doesn't actually say particle in the name for some reason, is dynamic parameter. Now, this is an extremely powerful tool. The most common way to use this node is in particle update. We can go dynamic material parameters, and we have the choice between these 4 floats to send through. So I'm just gonna disable the last 3, and we're just gonna use number 0. And we can specify literally any parameter from this particle thing to get sent into the material. So we can say curve, float from curve. We could make the curve index just the normalized age as usual, but we can give this curve some wacky properties. So we could say add a key, add another key, add another key, and just make this curve go kind of, you know, wild. It's wildin'. And keep in mind, we can make this go above 1 and below 0 if we want. So it is really easy to just create, you know, specific curves for specific effects. And so now we're getting the normalized age, running it through this really wacky ass curve, and we could go to our tutorial particle thingo and use this parameter in a lerp to lerp between, I don't know, 2 colors for whatever reason. And now you can see in our particle thingo that these particles are alternating between blue and green based on this curve thing. If you wanted the fade out of these to be more controlled rather than just using the, you know, the alpha from the color or something, we could just say dynamic material parameters. Let's just get a nice pulse out curve. Let's actually use this to drive the opacity of our particle rather than the alpha of the particle color. Even like an up and down thing. So you can see that it fades in, gets to its full opacity halfway through, and then it fades out. And, you know, that's just a way that we could use this in a particular way to get a particular effect. So that's an extremely simple way that we can use the dynamic material parameters. Now you can also do this on particle spawn, and this will set the dynamic material parameters as like a one-off. So we could get the lifetime of the particle, which is like the lifetime that's determined at the start, and these particles are lasting between 5 and 10 seconds. Let's get this, divide it by 10, so that 10 seconds is 1, and 0 seconds is 0. And let's just lerp between, again, 2 random colors. Put that into the base color and emissive. So now in our material system, the ones that last longer are the green ones, and the red ones will always fade out before the green ones, if that makes sense. So we're getting the initial lifespan of the particle and using that to set some value in the material, whether it's color, whether it's opacity, whether it's anything. So that just goes to show that you can set a one-off material parameter with the dynamic material parameters thing. So I think that kind of covers every way that materials interact with particles, or how particles interact with materials. Obviously, this is just scraping the surface, but I hope that it kind of gave you all of the tools, showed you all the tools at least. I guess with that, we conclude the video. And now is the time that I remind you to like the video, share it with your friends, subscribe to the channel if you want to stay up to date with all the upcoming videos and stuff. If you do want to support monetarily, you can do through the Patreon for as little as $1 per month in the... And so I guess with that, we say goodbye. Goodbye.